Good morning, dear students. Again, I'm back with the new topic called the passive component. This is the last topic of our CMOS design, the fifth unit, passive components. Now, what are the passive components? We are going to discuss in this topic what and how they are designed or how they are fabricated using the CMOS fabrication technology. Now, as we know that we are having basically the two passive components what we deal in electronics are the resistance and the capacitor. The resistors and the capacitor are called the passive components. Now, we are going to design about the passive component model. Discrete passive component model are quite easy to model. Now, resistor and the capacitor can be generally be modeled by ideal and capacitor respectively. Following figure of the merits are used to characterize the passive component. Now, we have certain parameters what we undertake for designing the passive components like resistor and the capacitor. Below I have described the different types of the properties of the resistor and capacitor for designing. Now, for the resistor we have to take the following properties. We have to take into account sheet resistance, the resistance density, the temperature coefficient and absolute accuracy. For designing a resistance, these are the four different properties that are included for designing the resistance property or of the resistor. Now, in a similarly manner, when we talk about the capacitor, we have to take the following points into the consideration: capacitance density, temperature coefficient of the capacitance, voltage coefficient of the capacitance and absolute accuracy. Now, we have seen that for the passive component model designing, we have to take into consideration the certain parameters for the resistors and the capacitor designing. Now, while doing the fabrication, we have to certain process have to be followed in accordance with the fabrication techniques. Now, we will move further towards the fabrication of the capacitor. Now, now we will check out how we are going to design the monolithic capacitor. Here I have shown you the three different diagrams depicting from the substrate to the formation of the capacitance plate. Now, first we have a P substrate and there is a region shown, the N region, and there is a silicon oxide layer. In the second we have a P substrate region and N induced into it, and then with the metallic diffusion 1 and 2 terminals are diffused across the N type. Okay, and the substrate is a P substrate. Now, dealing with it, what is capacitor? Any structure in which voltage induced separation of the charge occur can serve as a capacitor. Now, capacitor is what? Capacitor is something where is a voltage. When you apply some voltage, there is a induced in the separation of the charges. For example, the positive and the negative charges are separated due to the induction of the voltage. That is called a capacitor. Now, when we fabricate it, we have to follow the certain steps in the process of fabrication. Now, first step, what we have to do first, we have to take a substrate P material, as shown that I have taken in the first diagram, figure 1, that I have taken a P substrate material. Then after taking the P substrate material, we have to go through this etching process and the diffusion of the N-type material into the substrate which forms the one plate of the capacitor. In the first diagram, we have seen that there is a P substrate material, then the P substrate material is induced or diffusion is done with the N-type material which forms N-type material which forms one plate of the capacitor. Then the SiO2 layer is formed over the wafer by passing the pure oxygen. Now, when Si plus O2 will be diffused in the form of the gas, there will be again a silicon dioxide layer. Then it becomes the inactive region for the above the N and the P substrate layer. The Si2 layer is reformed over the wafer by passing pure oxygen. SiO2 acts as a dielectric of the capacitor. Now, in the second diagram, when we form the SiO2 layer, it forms the dielectric medium above the N-type material. The oxide layer is etched and the terminal 1 is added. Now, you can see the terminal 1 with the metallic connection. We again etch the SiO2 layer and to a certain region, and then we drop the metal into it, and terminal 1 is attached to it. Similarly, we is the second terminal, and we drop the metallic connection with the second point. The oxide layer is etched and the terminal 1 is added. Metallic electrode is deposited on SiO2 layer and forms the second plate of the capacitor. Now you can see the two terminal 1 and 2 between the n-type. So there is an oxide layer, in between there is an n-type material. It exactly forms like a capacitance. SiO2 layer is a layer which provides the capacitance between the point 1 and point 2. Whenever the voltage is induced between 1 and 2, the charges will be, there will be the charges induction or the charges separation. Accordingly, either a positive charge will come on the one side and the negative charges goes to the towards sides. Thus this structure act as a monolithic capacitor. So this is the process of designing a capacitor via capacitor in the IC fabrication process. Similarly, we'll be talking about the next topic, that is called the monolithic resistor. We have a different steps for designing the monolithic capacitor, monolithic resistor. Now in monolithic resistor, it is similar to the formation of the PN junction. Now as in PN junction, the depletion layer is formed. The depletion layer actually obstructs the flow of the current. Also in PN junction, there is obstruction generated through the depletion layer between the PN junction. In the similar manner, PN junction acts as a resistor to the two metallic points. Now we are going to design the similar structure according to the fabrication process of the resistor. Now first of all, in the first diagram we see there is a P substrate and a N island is formed. There is a P substrate and N island is formed. Then what we have through the process of the etching, in the second diagram, through the process of the etching, a window is opened. Window is opened at the center of the SiO2 layer exposing. Now we will remove the SiO2 layer. In the second diagram there is a window, what is depicted in the figure is shown. Then an epitaxial layer will be grown. Then there will be a SiO2 layer exposing the N epitaxial layer. When we remove the SiO2 layer in the form of the window, there will be a N region will be epitaxial layer that is developed. Then after this we are going to diffuse the P-type material into the N-type material. Now as you can see, there is a well of P well is induced or diffused in the N well region. P-type, the diffuse of P-type material into the N-type area. Then the SiO2 layer is reformed over the wafer by passing the pure oxygen. Now through that window region again is covered with SiO2 layer by reacting it with the O2. Then the terminals, in the similar manner, the terminals are developed. Two terminals with the metallic points are developed through the etching over the P island. Now we can see that it is 2 points can be act as a diode, because the P region it will be the P and N region will be as if a depletion layer is formed between the 1 and 2 point, and thus it will be the designing for the monolithic integrated resistor through this IC fabrication process. Thus in today's lecture we have discussed about the passive component. The passive component are of two types, the resistor and the capacitor, and we have seen that the resistor and the capacitors, how the resistors and the capacitors are developed according to the formation of the IC fabrication process. Thanks, and we will meet again. Good day.